Welcome back to another episode of Earth is Our Home with Dr. Thomas Blaine. Today, Dr. Thomas Blaine is going to be talking about climate change and a number of different questions that individuals ask and he wishes to address. So stay tuned. Welcome back to another episode of Earth is Our Home with Dr. Thomas Blaine. Dr. Thomas Blaine is an associate professor with the Ohio State University. And as individuals have seen in our previous shows, Tom brings a lot of information about climate change. And today he's going to be addressing basic climate change questions. This is one of a series of telecasts that's going to be addressing what individuals need to be aware of when it comes to climate change. Tom, always a pleasure talking with you.
It's always a pleasure for me to be on here, Patrick. This wouldn't be possible without you. You're an excellent co-host. This is our 5th season, and I'm really excited. We did the update, the 2025 update, a few weeks ago. Folks can look at that and go back and watch that. But right now, we're getting ready to do this mini series in Earth is Our Home, in which we're going to back off looking at the short-term fluctuations in global temperatures that we've been focusing on really for quite a bit of the past 2 years. So we're calling this one Addressing Basic Climate Change Questions. Backing off from the short run, please go watch those to look at that and look at the future going out. But here, these are the most basic questions. I want the viewers of Earth is Our Home to be able to answer these questions. Questions about global warming and climate change. The public deserves these answers. I am on the faculty at Ohio State University. I'm an environmental economist. Part of my job is to take the university to the public. And that means my specialty of environmental economics, subjects within that, which include global warming, climate change, and make those clear to the public. You know, these are 7 really, really basic questions. But the vast majority of Americans have heard these questions asked. They even get into discussions about these questions. But the vast majority of people can't give good answers to these or thorough answers. And really, I think that's my fault, for example, for not doing a better job of getting the answers out to these questions to the public. So we're gonna go through these. Let's look at this. Isn't it true that Earth has been much warmer in the past? So why are a few degrees now such a big deal? Earth's temperature, climate always changes. So again, why is temperature, climate change now so important? 3, is it really true that we're in an upward long-term temperature trend on planet Earth? We have some more here. How do we know that the temperature changes we're seeing are man-made instead of nature-made, since temperature changes have always occurred? 5, is the current warming trend bound to continue, and is it set to lead us to negative consequences, including climate disaster? 6, what can we do to turn the trend back, or at least stop it in order to avoid a catastrophe? 7, is sea level rise a serious threat to our coastal areas, and what can be done about it? So we're going to go through this, and hopefully you'll be able to have answers. There's always come back here, to look back at these questions and then think in your mind where we address those various aspects and what answer you would provide now if somebody put you on the spot based on what you've learned on Earth is Our Home. The first thing I want to do is get this out of the way. My fact sheets and everything are called global climate change. But if we're going to talk about global climate change, a lot of people remind us that back in the 80s and 90s, when this subject started, the topic was global warming. And somewhere along the way, it became politically incorrect to say global warming. You had to say climate change. But I've never been concerned about being politically correct. To the extent that we see climate change at this time, it's the result of global warming. And warming, by the way, temperature change is a lot easier to observe and quantify than climate. And, like I say, if the climate's changing in any way, it is the result of global warming. So it's okay to say global warming, and you'll hear me say that from time to time. In fact, now that we're onto that, we have the satellite data. I show you this nearly every month. It started in January 1979. We've already got April of 2025 up here. You can see the trend is an upward trend. We've warmed from about 0.3 of a degree below the baseline to about 0.5 of a degree above the baseline. That's Celsius. That's 0.8 of a degree, or about 1.4 to 1.5 degrees just in these last 45 years or so, from January of 79 to the present. We show this a lot. But again, we're not going to focus now on why these ups and downs have occurred and the trends. Those are in previous shows. Go back, go to the main page, scroll down to some of the recent shows, and we talk a lot about this.
Increasing the temperature by one degree doesn't seem like it's really of great importance.
That's one of the questions. Remember, we had one of the questions
Right.
was why is a few degrees now, such a big deal? And so that's one of the questions that we've got to answer. So we have seven. We have seven, remember? And one of them was, is the Earth really warming or not? And this is the temperature data since January 79. Each blue ball is a month. This is very significant warming for that period. If you're talking about 0.8 of a degree Celsius or 1.5 or so degrees Fahrenheit, that is substantial over a 40-some year period. It's not typical for that to happen on planet Earth. And again, we're not going to do the short term. I wanted to reiterate that, but we're going to do longer term things today. What's driving the upward trend is the increase in carbon dioxide that we're putting into the atmosphere through burning fossil fuels, coal, oil, and natural gas. So now we're going all the way back. We began to measure carbon dioxide in the atmosphere very carefully in 1957. And so we've got that. You can see that trend. Like I said, we stretch it back. If we go back and look beyond the 1979 satellite data, Earth's temperature has increased not 0.8 Celsius, but 1.4 degrees Celsius, which is about 2.5 degrees Fahrenheit, 1.4 Celsius, 2.5 degrees. So you can see how over time it's expanding. So nobody's saying it was a disaster that we went that increase from 1979.8 degrees to the present. But if we go on back to the beginning of the industrial era, It's not 0.8, it's 1.4. And as we continue, it's going to increase well beyond that. I just want to remind folks that the difference between Ohio's temperature today and 25,000 years ago, when most of Ohio was under an ice sheet a mile thick, we were like the North Pole in Ohio. That was only about 10 degrees worldwide temperature. A worldwide temperature decrease of 10 degrees takes us from what we've got now to an ice age. Just 10 degrees, because the temperatures aren't uniform and you don't get that much cooling or warming in certain spots like near the equator. 1.4 degrees C is quite a bit when you consider that 10 degrees C difference puts us in an ice age. 10 degrees hotter would destroy agriculture on planet Earth. It would put us into a catastrophe. Here's the El Nino. We always talk about El Nino and La Nina. What's affecting temperatures in the short run is the El Nino, La Nina. And you see we've had some switcheroos. We had a strong La Nina and then an El Nino that didn't last real long. And now we're back in La Nina, which is what is responsible for the temperature, which peaked out a year or so ago. You look at that peak way back there at the beginning of January of 24. That was a record at the time. And the temperatures fallen back just a little bit since then due to La Nina. Okay, so I told you we're going to look at the bigger picture. And here's the bigger picture. We didn't have satellites before 1979, but we did have thermometers placed around the world. You can see that the trend, if you look between about 1850 something and 1920 or so, there really wasn't a trend. And that's because the amount of CO2 in the atmosphere was still fairly constant. The Industrial Revolution had gotten started, but much of the world was not industrialized. And so you see how little the change was in there. Look at that red line. There were short-term deviations. Yes, we know those are caused by El Nino and La Nina, but the red line in there for the first 65 or 70 years of this graph, it barely budged. But by the middle of the 20th century, the amount of CO2 was starting to accumulate in the atmosphere. And that set us off on the warming track that we're on. If you look down there, 1980 and go up, you'll see that's about when 79 or so, that's about when we started the satellite data. But the temperature had already started going up, and that's why there's a difference between what the satellite data says and what the land record, this one, says for overall temperature, and why we say Earth has warmed 1.4 degrees Celsius since the industrial era began, but 0.8 degrees of that has been in the past 45 years. Now, that's the majority. That means there's been more warming since 1979 than there was in the 100-year period prior to 1979. More warming since 1979 than during the era, 100-year era prior to that, making for a total of 1.4 degrees Celsius since the Industrial Revolution began. Is that a lot? Well, it's 15% of the change from this planet going the other way to the ice age. So we know 1.4 degrees Celsius is significant, especially when the trend is continuing. If you look here, one thing a lot of people say is about the natural aspect. We already showed El Nino and La Nina are natural. But this warming we're seeing, this is a great graph because it shows very clearly that solar forcing is not responsible. Solar forcing is not responsible for global warming here. Look at the red line, that's temperature. Look what happens to temperature around 1960. Okay, the red line goes up, 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 and you can check that out. The yellow line is solar irradiance. It's a measure of solar forcing. Look at that. Over the last 60 to 65 years or so, solar irradiance has been going down. So if people tell you, and a lot of people naturally just, it's like a talking point. They say, oh, well, it's natural. It's probably the sun. Well, it's not the sun. And here's the graph to prove that it's not the sun. The sun is not driving this current warming. Compare this graph to the CO2 graph. CO2 is driving the current warming. And it's getting there by humans putting more into the environment by way of burning fossil fuels, coal, oil, and natural gas. That's for our electric plants, our automobiles, boats, ships, airplanes, and so forth. Now, I want to finish this today by telling you something. The CO2 global warming relationship is not new. It was first discovered and confirmed by scientists in the mid 1800s. So a lot of people also come along and say, oh, the scientists are talking about this now. It's a new thing. No, it's not a new thing. John Tyndall wrote in the 1850s and did a lot of very sophisticated experiments. He was an atmospheric physicist. So that was his thing that he did, was study the atmosphere, how different gases in the atmosphere contribute to changes in temperature. And he did that. Now, that the first person to show, that's right, the first person to actually show that CO2 would contribute to warming was not John Tyndall, although he gets a lot of the credit. It was a woman, and her name was Eunice Newton Foote, an American physicist. She, in 1856, she set canisters of CO2 near canisters made up of other gases and let them receive sunlight and the reflected sunlight. She showed that the containers with carbon dioxide warmed more than the other containers, proving that CO2 traps heat. That means, in today's terms, it's a greenhouse gas. It's a greenhouse gas. Now, her experiment was a rather simple experiment, but we're talking 1856. And the truth of the matter is that Eunice Newton Foote did not get a lot of credit, partly, you could say, because the experiment was a simple one. But when you're starting a new science, the experiments are going to tend to be simple. But a lot of the reason she didn't get the credit was, let's be honest, she was a woman. I ask you to name the top 10 scientists prior to the 20th century in the world, or up into the mid 20th century, you'd probably name all men. And, certainly men have been higher represented in science than women. But I just want to give a shout out here to Eunice Newton Foote, because number one, when you say this is modern professors pushing this narrative, you're wrong. This is not new. And in any case, Eunice Newton Foote, 1856, was followed up by John Tyndall in, I believe, 1859. His article came out. His set of experiments was much more complicated than Eunice Newton Foote's, but they showed the same thing in the long run, that CO2 adding to the atmosphere from the burning of fossil fuels will continue to create more warming in the atmosphere.
I think it's very important what you're saying about the global climate change, but it's happening over a period of time to where most of us really don't recognize. We see the earth change slowly. And so there's always a concern that we've survived this far, we'll continue to survive.
Yes, and that's bad thinking. That's really bad thinking. And I'm glad you mentioned it. So look at number one. Isn't it true that Earth's been warmer in the past? Well, we didn't go through that today. We didn't quite answer that, but we're going to talk about that next time. But the question I think you're asking is, why are a few degrees now such a big deal? Well, as you pointed out, we're talking about 1.4 degrees Celsius in just, 150 years or 160 years or so. But we pointed out a few degrees, 10 degrees Fahrenheit, all right? 10 degrees Fahrenheit, which is only about a little over 6 degrees Celsius, separates today's Earth from an ice age Earth. If you go the other way from today's Earth to 5 or 6 degrees warming, which no, we're not going to get to real soon, but eventually, if we continue to burn fossil fuels, it appears highly likely that we will. Maybe by 2100, maybe sometime later than that. We do have time to reverse course. All right. That gets into number two. It's true that we've had temperature changes, as you point out, in our lifetime since the Civil War, since World War I, since World War II, since the satellite data in 79 and 80. Why is it so important? Because if we extrapolate on this by burning more fossil fuels, as appears to be the case, because the world population is 8 billion. It was only 4 billion when I was a kid. It's doubled, and it's still growing. And more people are getting automobiles. They're riding in planes and boats. They're getting central air heating. And so we're burning more fossil fuels now than ever before. And so that's why a lot of people are saying this, is something to be considered very serious now. You and I, we won't live to see a collapse in Earth's ecosystem. We won't live to see it. But we're still headed in that direction, even if it takes another 50 to 100 years. We're still heading in that direction. And that's why I'm wanting to answer all these questions. I want everybody to be able, look at number 6. What can we do to turn the trend back, or at least stop it in order to avoid a catastrophe? There's no catastrophe coming between now and 2030, even between now and 2050. Okay. But it's a very slow thing. The hour hand on the clock, you can't see it move. But if you leave and come back later, it's moved. And that's the way global warming is. Right now, we're looking and saying, okay, we can't really see any changes from year to year, or maybe even from decade to decade. But if we fast forward 100 years and Earth is 3 or 4 degrees Fahrenheit warmer than it is right now, already with 1.4 degrees is the Celsius, that's 2.5 If you add another 3 or so, we get it up to 5.5 or 6 degrees Fahrenheit. It won't be the world we know. The agriculture we have is not suited to that. The flora and fauna that we have are not suited to that. They did not evolve in that climate. And so we're courting disaster in the long run.
Well, Tom, I look forward to the upcoming videos that delve and greatly go into the question that you have posed on the screen.
Looking forward to it too, Patrick, because we got a lot of great data. I hope the viewers appreciate the data. We've shown them the most recent data on El Nino, satellite temperatures, surface temperatures. We've shown them a lot of great data. We gave them some good education today about how scientists figured out almost 200 years ago that global warming is caused by CO2 in the atmosphere. It's not a newfangled thing. We're going over some real good stuff right now. And, if it takes you a second time of viewing, you might want to view this a second or even third time because we're throwing a lot of information out there.
Hey, we're talking with Dr. Thomas Blaine. Tom, thank you.
Thank you, Patrick.